Good evening, everyone, and welcome to today's session. So today we are going to look at another managed database service, and that is RDS. Sorry, that is Amazon Aurora. Yesterday we looked at RDS. Today we are going to look at Aurora. Now, Aurora, unlike RDS, is a proprietary technology for AWS or from AWS. That which means if they say a service or a software is a proprietary service, then it means it is not open sourced, right? It is not open source. It belongs to AWS alone, and it supports Postgres and then my SQL. So it means that your drivers will work if or as if like Aurora was just a normal Postgres or my SQL database, right? So that's and then it's 5 times let me say it performs 5 times better than my SQL on RDS, and then it's 3 times better than Postgres on RDS. All right, so more or less like has a higher performing, or it's more of higher performing stuff than RDS or the Postgres or my SQL on RDS. And then the storage scales automatically, and it's in increment of 10 GB. So it starts from 10 GB, increases to 20 like that, and up to 128 terabytes. So it starts from 10 GB up to 128 terabytes. You can also have about 15 replicas, right? I'm reading this from my notes. That is why I'm not sharing my screen, but it's just let's say a preamble for all of us before we get into the practical aspect of it. Some of these things that I'm saying, we'll see them when we are launching it. It's not free anyway. So for this one that we are coming to do, I'll be charged some small money, right? So and check, I do it, I will stop it and then delete it so that it doesn't cost me more, right? So as I said, you can have up to 15 replicas, and then the replication is very fast than the normal, my SQL, right? The lags is just something under 10 milliseconds. Fast, no, not hiding, not a. And then the failover too is instantaneous. So it's like when you do a multiple AZ and then you are doing a failover, it's just like I don't know how to put it. Even when places that have like faster changeovers, immediately ECG power goes off, then the changeover happens. You don't even notice that the light went off. That is how Aura is even faster than that. So it means that it's you don't even notice that something went wrong or one server failed or something of that sort. And it is also, it costs 20% more, right? Even though it is more efficient, but it costs 20% more than RDS. So I'll open my my Jamboard again, and then we'll do some drawings before we go into the practicals. So Jamboard. Today I will use the pen again so that I can draw faster, even though they are horrible. Let me clear this frame. Okay, I'll just use this frame. So let me remove this. Now, with Aurora, your data is spread across 3 AZs, and 6 copies of your data is created across 6 availability zones. 4 copies will be needed for writes, as while 3 copies are needed for reads. Right? 4 copies of the 6 copies of the data are needed for writes, whilst 3 copies of them are needed for reads. It's also self-healing with peer-to-peer replication, right? We know what peer-to-peer connection is, and the storage is stripped across hundreds of volumes. So for that one, we don't know, but it's over hundreds of volumes. So this is how it works with Aurora. Let's say I have, let me delete it. I will just use the pen. Uh-huh. Right. So I have AZ1, AZ2, AZ3. Right. This is what happens. If one data is created, it creates two here, creates two here, creates two here, like this. Okay. So 6 copies. And then when you create like that, so you populate it just like that. Now, one instance of the Aurora is used as the master. All right, takes the master, and this is for writes. Okay, the master is for writes, and then you have the 5 other ones as read replicas. So all these are reads. All these, apart from this one. Now, the read replicas, the read replicas can be converted, and it's automatic, right? During failovers, immediately this one fails, and then let's say the failover is coming to this one. This one automatically converts to the master, and then now it takes what is used for writes purposes, and that is done in less than 30 seconds. And it also supports cross region replication, right? So this is like uh 6 copies or 6 replications of your Aura instance. Only one is used for master by default, and then the rest are read replicas. When this one fails, a failover occurs, and then this one is now converted to the master, and then it's now used for writes. Okay, while this one heals, it also has self healing, so it heals itself. So till it comes back to its normal functioning state, you will still have the master elsewhere. Great. So that is a basic information about Aurora. We'll go into the advanced concept, but this is the idea that we should keep. Then as we move on, I will explain other things as well. So on our console, we'll go to RDS, right? So it's RDS Aurora. So it's under the relational database, right? And then I'll create database, and I'll choose Aurora, right? So there is Aurora MySQL and there is Aurora Postgre. But for here, we choose Aurora, and then the same thing. If we want to filter out the options, we can choose to. So these are different engines, right? And then for here, we have only two templates, either production, dev, or the dev or tests. Credentials, admin, you can type a password. This one will not log in into it because any operation that we do, it prolongs the period that I'm using it. So may cost be cost. Good. And then we can either go for the standard or the IO optimize. So if we kind of do a lot of input and then output, or read or write, that is basically it. A lot of read or write, then we have to go for the IO optimize, right? There is no additional cost, but then the cost is what, over 25% of the total database cost. So we'll stick with the standard. Okay, even though it's not free, but I'll stick with it. And then for the instance configuration, you can either go for the serverless. So with serverless, it means that everything is managed, right? Talk of auto scaling, in fact everything about it is managed. But then, even though by default everything about Aurora is still managed, but this more or less like a more advanced, or how do I put it? Yes, let's say a more advanced management of things. Everything entirely is automatic. Talk of backups, talk of replications, talk of scaling, and all those things, right? You can also choose a memory optimized, and then there's also bestable class, right? So we'll go for the bestable class, and then we'll go for a smaller, right? So we'll go for a small instance just to reduce our costs. So if I search for small, a small name, if there is no small, so that's the medium. Okay. Oh, let me see the memory optimized and see if you can have a smaller one. Hey, you have removed all the small from inside. Okay, so then let's use the bestable, and then we just use the T3 medium. Great. So this is, as I said, by default, Aurora does replication, but this one also means that like you are doing like extra replication for maybe cross region or something. So create an Aurora replica for fast failover and high availability. We'll not go for this. We'll just don't create Aurora replica, right? And then this time you're not going to connect to an instance. For VPC, we choose default VPC, and then yes, as usual, it should have public access. For subnet group, we'll leave as it is, or we can choose to create a new VPC and then put the subnet group inside, right, for our database. So we can create a new VPC and then put it inside, just for, so that our subnet group is just for our DB instance. But since we don't have anything in our default, anything launched into our default VPC, we just stick with this one. Yes, public access. And then for security, we can choose either the default or we can create a new one, but we'll also leave it at default. And for AZ, we'll not have any preference. We'll just allow the DB to do this for us. For proxy, I'll explain proxy as we move on. Right, so I'll leave it. But proxy is more or less like um another managed service. What it does is, no, let me leave it, and then I'll go into that, right? So I will leave proxy here. So we don't want proxy. Read replica write forwarding. We'll also leave this one. And so bit here. Right. So it also issues write operations from the reader DB instances within the same DB cluster. We'll leave it. And then I explained IAM authentication yesterday. And then there is also Kerberos authentication, another authentication service through AWS Directory Service, right? Mostly for Microsoft Active Directory. And then for IAM, you're able to assign some IAM roles for, the IAM user, or even resource. Let me put it, for the IAM resource to be able to, or the resource that has the IAM role to be able to access the database. So you can see my DB total is what, 59 USD. Right? But there's no upfront. It's the estimated monthly cost. Okay. So we can go ahead and then create. And after database is created, I'm just trying to check. And then yes, for network type, you can also have either a dual stack or what's it called, an IPv4. Right? But the dual stack is just for multi-IP. So either IPv, you can communicate over IPv4, IPv6, or both at the same time, but we just stick with IPv4. Okay. So after we are done, we can just create our database. I will have to create it so that there are some things that we will have to learn or talk about. So I'll close this. Great. So let's wait. It looks like there is something that I didn't select. We should have two instances here, the reader instance and then the writer instance. If it doesn't come, that means I didn't do it well. I'll do it again. I probably skipped something. All right, so the database takes a while to set up anyway. So yeah, we can go for talk.
So with the type of engine,
Yeah.
is it only MySQL or there are other engines,
No,
Postgre and
so
the others?
yeah, so Aurora supports two, either Postgres or my SQL. Right, so it's Aurora for Postgres
Okay.
and then Aurora for MySQL.
All right.
And it looks like I skipped some. Looks like I skipped something because I should have a reader. It is a writer instance. Huh. I skipped something. Okay, but then that is fine because you should have a writer instance and then a reader instance. Probably because after I skipped the multi AZ. I think there was another, yeah, there was another option that I should have ticked, right? So it will create a writer instance and then create a reader instance. Unless I'm the one not having patience to wait for all of them to finish. But all should come at once and then it will start creating it. But then let's go into as to the things that we can do. So I can even modify it. Let me see if I can choose the so parallel query is off by default. Okay. Default. Yes, so for maintenance, for options, you can also it's just the same as RDS, right? Most of the things are the same for RDS. It's just as how its architecture is. That differs, right? Okay. So these are some actions that we can perform. Okay, so let me add a reader. No, it will cost me more. But then let's just understand the concept behind it. So I can add a reader, right? To even though I created it without a reader, but I add a reader instance and it will be added to to my instance, and it will take the same settings that I configured as when I started earlier, right? We can also create a cross-region read replica. Okay, we can clone the database. We can set up a Lambda connection. We can set up EC2 connection. We can add an AWS region to the database as well, right? And then we can also take snapshots. Now, snapshot is a form of a backup. Now, in what cases would you use snapshots? Because even though the Aurora database itself creates or backs up your data, right? And you are able to actually restore your data to any point in time. So you can even restore your data like the next minute, right? But there is a retention period. Okay, there is a retention period that is also from 1 to 35. And the thing about Aurora is that so you lose like these settings have been updated because we didn't even see them. It starts from 1 to 35 days, and for this kind of backup, you can't for Aurora you can't disable it. You can't disable it. So the minimum you can go is 1. Okay, so for snapshot you can keep it forever as and when you don't need it. The next thing is that most of the time you would want to maybe you are just using a database for some 20 minutes, right, for some queries or for some data analysis. After that you will not need it. Maybe you use it once a month, and then in every month you use it for just 20 minutes. So instead of starting it and then stopping it, because if you stop an instance, you are still paying. If you stop a database instance, you will still pay for the storage that the database has used or is using while it's stopped. So the cost effective way, or one of the ways to save cost, is to anytime you are done, you take a snapshot of the database instance and then you delete the database. Mhm. Then you delete the database. The snapshot is also going to cost you for the storage, but it is lesser, right? It is lesser than you just stopping the instance. So that is one reason why you would use a snapshot, right? So we call it snapshot and restore. Snapshot and restore. So instead of starting and then stopping your instance when you don't need it, you can do a snapshot and restore. Great. So I think that was and then there is also a database backtrack, right? The backtrack is different from restoring to a point in time. So backtrack is more or less like, okay, you are reversing your database to a certain date. Okay, send me back. Go back to your day, your previous 1 minute, your previous 5 minutes, or your previous 2 days, your previous 3 months. So that's for backtracking. And then restoring to a point in time is a period where maybe when a certain backup was taken. Okay, so you are restoring to that backup, and then backups, a full backup is done when you are at the end of your window or your backup window. So in a certain backup window, there's a full backup that is done. But backups of each transactions, so there is a transactional backups that is being taken anytime you perform a transaction. Then there is a full backup that is done during your backup window. So let's take note of that one as well. Now, to be able to delete this database, so that's more from it. And then for the S3, you can take a backup of your database on-prem, right? And then you save it in an S3 bucket. So when you save that in an S3 bucket, you can now restore it from an S3 bucket, right? You can now restore it from the S3 bucket. And another thing about Aurora is that since it creates read replicas across multiple AZs, it uses a shared volume kind of. So these three AZs shares the same storage. right? So the storage is like stripped across the AZs. That is why I said it's stripped across hundreds of volumes across AZs. So in the exam, the key point that you should note is that when you hear something that it has a read, I mean it has a write and then or a writer and then a reader, or it has auto scaling, or has a share volume, or can be able to or can backtrack, then you are looking at what? Aurora, right? So to delete it, I have to first come to the instance, either the read or write instance, go to actions and delete it. Okay. Okay, so I have to first modify it. So let me go to the main one, modify. I have to disable the delete protection, just as we did for RDS yesterday. So I'll scroll down and continue. So databases. So I'll first, so you can see the stop is not like actually stop entirely. It was stop temporarily. So I'll first come here, actions, and then delete this one. Oh, okay, I have to modify this one as well. Oh, I didn't disable this. I have to choose apply immediately. So I didn't finish it and I went back. Hmm. Okay, then I'll type delete me. Okay, first wait. Let me do the add read. I'll not add, but I'll cancel it or something. So I can add a reader, right? And then you let me just add it. So I can add a reader and the instance identifier. I can choose to add type a name. So let's say read instance. And yes, the same. The reader is publicly accessible. Failover priority. So I can choose any of them, tier 1, tier 2, tier 3, up to what? 15, right? I'll leave these ones and add. So you can see it will be added. Look at the Basa name that I typed. So you see I have a writer instance and I have a reader instance. When you are doing the initial setup, you'll be able to do that. I probably skipped it because I was more or less and then this is the failover option, right? So in case maybe this one is not responding, my writer is not responding, I can just click on failover and then right it will switch, right? And then it will switch to, but let me cancel it. Okay, so I can now delete this, delete me. So I will have to wait for these to be deleted before I can come back here and then delete the bigger boss. Let me see if I can do the delete as well. So you can also choose to retain automated backups. I will not create any final snapshots. Let me just do delete so that Nihina Beko at once. Type delete me into the field. And well, that's what I've typed there. You strongly recommend. Have you? Okay, let me acknowledge. Good. Delete the cluster. Okay. So these will be deleted. Now let's look at certain concepts. I'll go back to the diagram. Let me clear the frame. So I explained that there is a master, right? And there is what? Read replicas. Let me use boxes. So these are read replicas. Okay, so we have 5 of them. Right. You have your client here. You have your client here. Now, what Aurora does is, normally the read replicas are made for, let's say, auto scaling purposes. So you start from the 6 copies, right? And then this one can go up to what? To the 15th. Now, we are all aware that each instance comes with what? An IP. So it means that anytime the instance scales, the IP is going to change, or the endpoint is going to change. Sorry, I said the endpoint. The endpoint number, or what you are going to use to connect to the DB instance, is going to change. So what Aurora does is they use what we call writer or reader endpoint. So for the master, we'll have a writer endpoint, and then the read replicas will have a reader endpoint. So this time around, the connection now comes to the endpoint, right? And then it's fed to the client. So the same thing, if the client is writing, now it will come to the endpoint. They call me by this time. 10:32. And then it now goes to what? The master. So that is what the writer endpoint and then the reader endpoint does. So it means that this one, the IP, the address or the endpoint address doesn't change. Okay, the endpoint address doesn't change. So in case this one auto scales, right? Auto scales, it will be added. So the connection hits the endpoint before it goes to the user or the client when you are writing to the same thing. So in case there is a failover, then if the failover hits this one, it's now isolated, right? So that it goes this way. Right? And as I said earlier, it can expand. Here so this 10 GB, 10 GB, 10 GB, 10 GB, 10 GB, till 128 terabytes. Is any question so far? So how do you implement auto scaling? So just like how we did auto scaling group, or we did our auto scaling, you can configure auto scaling for Aurora as well, right? And then you can tell it to scale, right? Scale up per a certain CPU usage. So if you want to, let's say you want to keep your CPU usage at 60%. So anytime it goes a little above 60%, it will auto scale. So another read instance will be another read instance will be added to it. This one you have to delete it before I leave you, right? So let's say you set your CPU usage to be equal to 60%. So anytime CPU usage goes above 60%, then another one will be added, right? So it adds like that till until you have exhausted the 15th instance. Now there is something also called custom endpoint. Now you remember that when I was setting up the EC2, okay, wait, I said EC2. When I was setting up the Aurora, I chose an instance configuration. Okay, so I chose T3 medium. Okay, so let's say I have two T3 mediums, right? So this one is also T3 medium. And then I choose to go for an R3, let's say large, okay, for these two. What it means is that they cannot, okay, they cannot connect to the same endpoint. So what you do is you configure what a custom endpoint, because the classes are different. Okay, the classes are different. So this time the endpoints have been separated for each other, right? So you can't have the same endpoint reaching the same read replicas or the same Aurora instances. So what you do is you configure a custom endpoint, right? You configure a custom endpoint for the other instance types or the classes. But then when you create a custom endpoint, generally the default endpoint or the previous endpoint will not be used. Okay. So when you create the custom endpoint, it means that these traffic can also be routed to the custom endpoint because you specified it. Right. So immediately when you create it, it will usually render this one null and void. Right. It will render this one null and void. Even though it doesn't get deleted, it will be there, but it won't be used because this is more or less like an efficient one. So this one will just be there and then will not be used. And I talked about proxy. Let me clear the frame. Now, for auto scaling, you are the one who does the configuration, right? Just like how we said auto scaling goes for EC2 instances. Now, for proxy, that's a serverless, if anything, that's a serverless option, right? It's a serverless option, and that one is somehow cost cost effective. So what happens is that you have your Aurora instances here. Okay. And it's like there are a lot of requests that comes in and out from your Aurora instances. Let's use Lambda, for example. Okay, we'll get into it as we move forward for Lambda and then proxy servers or proxy fleet. But I'm just trying to give a general understanding or a general explanation of it. You know, we can have, because Lambda is more like function based and then events kind of thing. So you can have a lot of Lambda events, either writing to or reading from your RDS database. They cannot respond to all of them, or it could put some stress or even open more uh, sessions or endpoints, right, based on the number of Lambda functions that are triggered or that are working. So you can have a lot of Lambda functions triggered at the same time, and it will open up more connection points. You don't want that to happen. So what you do is that you create a proxy fleet, right? So all the requests that are coming will come here, okay? And then what the proxy does is it pulls the connection here. So you are not directly connecting with the server or the Aurora instances. What you are doing is that you are accessing from the proxy fleet, right? And then for this one, it's automated, it's serverless. So it scales based on the usage. And then you pay per second, right? So you don't need to plan your capacity. You don't need to manage anything, right? So if you have use cases that are kind of unpredicted, right? And then there are some intermittent surges and then all that, you can go for the proxy option. And it also uses the same shared storage volume concept that I spoke about earlier. And you can also set up a multi-master for the Aurora. Like you can also set up a multi-master when you have kind of work that you do like continuous writes, right? You have a lot of write works that you do, then you can set up a multi-master. So what multi-master does is that it will have multiple writer endpoints. So when you write to one, it replicates the data, right? So you can also have the master in the middle here, right? And then you have like the client is here. Okay, the client is here, and it does like multiple database connections. What it can do is that this one will take it, replicate the data here, replicate the data here, this way. Okay, so these ones are all master, right? So the user can write, so it's a multi-master setup, right? All you need to do is that you create it, and then you, just like how I added the reader instance, right? You can also do that. You don't need like some heavy coding to set this thing up. The only thing that you need some heavy coding to do is elastic cache. So elastic cache there, we'll reserve it later. Maybe when we get to the database option on our canvas, then we'll look at it proper. And you can also do what we call a global Aurora. So global Aurora, then we are talking of a cross region kind of database, right? And it's mostly recommended or useful for disaster recovery, right? It's mostly useful for disaster recovery. So in case you have maybe one region hit, or one region hit by some natural disaster, and then you've lost that one, then you can just cross over to the one in the another region. So you have one, just like the normal Aurora setup, you have one primary region for read and write, and then you can have up to 5 secondary regions. So the master can be used for read and write, the master region. So you have your master region. Let me clear. You have your master region, right? That has the read and write. So the master region, so region one will have the write, okay, and then it will have the read replicas as usual. So you can do a write, and then a read. And then you have region two, Okay, you have region 2 that has what? Read only instances till there is a disaster, and then this one is not working, and then there's a failover that goes, and then you have one master for write and then the rest for reading. And you can also have up to 16 read replicas per secondary region, up to 16. So this one can have up to 16. If you have region 3, you can have up to what? 16 as well. And promoting to another region for disaster recovery is just less than 1 minute, right? It's just less than 1 minute. So you can see how efficient this one is. And then for replication, so there is crossover, right, for failover, and there is replication. Now the crossover takes less than 1 minute, and then cross-region replications also takes less than 1 second. So it's just like a twinkle of an eye, and then or a blink, a blink of an eye, and you have your data also replicated across regions. And you can also use Aurora for machine learning. Okay, so you'll be able to use machine learning services like SageMaker and Amazon Comprehend, right, for sentiment analysis. Okay, so you have an application here that makes an SQL query, okay, to Aurora like this. So there is an SQL query for maybe products, right? The best performing product, or who is the best footballer worldwide. Okay, there is machine learning here. So you have either SageMaker or you have Comprehend in here. So what Aurora will do is that it will query who is the GOAT, and then these ML based on user sentiment and then based on some data that they have learned to now feed Aurora, and then it will feed the application. Okay, so you can use these for fraud detection, you can use it for ads targeting. That is why you go to Google and then go and search about TVs. You go to Facebook and then you are seeing ads on TVs, right? You go to YouTube, you search on videos on cars. The next thing you are seeing, the next social media website that you go, you are seeing cars there. So these are machine learning modules, right? They can use it for product recommendations as well. So you realize that of late, if you take like, or if you try to look for food ordering services online for the next 1 or 2 weeks, you see that all the video ads that you even see on Facebook, you see on Facebook, YouTube, will all be about food ordering apps. If it is not Yango, so if it is not Bolt Foods, is Jumia Foods, right? If it is not Jumia Foods, is what this one, Habtel. There's another one that I've forgotten. So that is also for machine learning. And then backups, I've already talked about backup. There is the automated one that does a full backup during your backup window. And then there's also the transaction logs that are backed every 5 minutes. And you are able to restore in any point in time, right? You are able to restore to any point in time from the oldest backup up to 5 minutes. And you have 1 to 35 days of retention. If you want to disable for RDS, if you want to disable it, you set it to 0. But for Aurora, you are not able to do that. And there is also the manual backup where you will do the snapshots and then restore. And you are able to retain it for as long as you want. Because even if you want to keep your database and then you just stop the database instance, you will still pay for storage. So if you plan to like stop a database for a long time, it is always best that you use the snapshot and restore. And then the only difference between the point in time recovery between RDS and then Aurora is the point in time recovery. So for Aurora, you are able to recover to any point in time, whether the previous 1 minute or any other time at all. But for RDS, you are able to restore to up to the previous 5 minutes. I talked about restoring from S3, right? If you have your data on premises, your database on prem, and then you want to just replicate the same thing on the Amazon Aurora or RDS, what you can do is that you put it into an S3 bucket and then you now restore from it. The difference between Aurora and RDS for the backup is that for Aurora, you need a software called Percona Extra Backup, right? This one. So far, that is the only one that is compatible for now, right? You use Percona Extra Backup to do the backup, and then now from the Percona backup, you store it into the S3, and then now you restore the backup file onto a new Aurora cluster running on MySQL. Or you can just do cloning. So in the case of cloning, you have your production. In the case of cloning, you have your production database, right? You have your production database, and let's say you want to test some 1 or 2 things, or you have some new things that you want to test, right? Taking a snapshot and then restoring it will take a long time. So what you do is that you clone the production DB, right, into a test or staging DB. Okay, test or staging DB, and then you use it for your test. If everything is okay, then you now send it to the BOSU or the master database, right? And it's very fast as compared to the normal snapshots and then recover. For security, you are able to protect the database for data at rest, right? Using encryption at rest. So you can use what? AWS KMS, where you have your keys and then or the access keys and then the private access keys. And you can also encrypt it in transit, right? Using a TLS certificate. So your clients or users needs a TLS certificate provided by AWS, right? To be able to encrypt their data in transit. So those are the security at rest, in transit. You can also do IAM authentication to make sure that not just anybody at all access your DB. And you can also use security groups to control access. And there is no SSH available except when you are using RDS custom, because RDS Aurora are all managed database services. So by default, there is no SSH available. But if you use RDS custom, then you disable the automation, then you are able to SSH into the underlying instance. Because if you do custom, then you definitely want control over certain underlying infrastructure. So you can also enable audit logs, right, to log certain activities. So that is it for security on the database. Great. So that is basically on Aurora, and then a little bit. Great. So my database is deleted. Awesome. So I can now close it in peace now that I don't have anything running. So that is basically about Aurora. I just wanted to explain it to you about everything in launching. It is almost the same as RDS. It's just the difference in how they work. So if you would want to also go through it again, I mean, you have to go through it again. Whilst if you are rewatching the video or you be rewatching the video, use it along with Stefan Marek's PDF. I took most of the notes from Stefan Marek's PDF. And if you have the video too, you can watch, I mean, Stefan Marek's video, you can watch it alongside so that you'll be able to get it. All right. So today I talked about Aurora itself and as to how it works, a little different from RDS. We talked about proxy as to how it works. And then we talked about the multi-master. We talked about the master or the reader, the writer endpoint that writes to the master instance, and then the reader endpoint that writes to the read replicas. I also talked about custom endpoint, where you have two different types of read replicas as in the instance configurations, right? That is where you create a custom endpoint. And when immediately you create a custom endpoint, the previous endpoint is not used, even though it doesn't get deleted, but it is not used. I talked about Aurora backups, that Aurora backups cannot be disabled. Okay, the minimum you can have, the minimum retention you can have is 1 day, and you can do a point in time recovery to any time that you want. But for RDS, you are only able to do the previous 5 minutes. And we looked at how you can restore Aurora, my SQL database from S3, right, by saving a backup of your on-prem on an Amazon S3 bucket, and then now you now restore the backup file onto the new RDS instance. And then when you go to database, you can see that there is an option to restore from an S3 bucket. And for Aurora, if you want to do the same thing, you will have to get the application called the Pecona Extra Backup, right, to do your backup and then now store it into the S3 bucket. We also talked about cloning, where you just create a copy of your production database, right? Kind of an instantaneous. So you just do the instant one instead of saving the back a snapshot and then restoring it right there. Cloning is more or less more faster than the normal copy and then paste. And then when you clone, another thing that I left, when you clone, it will also start with the initial 10 GB, right? It will also start with the initial 10 GB. And then as updates are being made, the storage will scale. So that is how beautiful it is. So it just starts with the initial database to create the clone, right? For you to be able to start working with it. And then it keeps updating. Since you are cloning, it has to take all the data or sync all the data from the old or the production area to the cloned one. So it will scale as and when it makes the update while you are still able to work with it. We talked about security of the database security, that you can use. You can encrypt data in transit, you can encrypt data at rest, and in transit it uses TLS. So as a client, you need the TLS certificate provided by Amazon to be able to um, encrypt the data. And there is also IAM authentication, where you assign IAM roles to resources or accounts to be able to access your database. This is to make sure that legit users are the ones that are accessing your database. And I mentioned also that you can also use security groups to control traffic that accesses or come into your instance. You can also enable audit logs, right, to be sent to CloudWatch for investigation or auditing purposes. And then by default, both RDS and then Aurora, you can't SSH into them unless you have RDS custom or you have enabled RDS custom. That is when you'll be able to SSH into the underlying EC2 instance. And there is RDS proxy that kind of pulls your connections, right? Pulls connections from the database or and then share it across resources. Okay, so it's kind of it reduce the pressure on the instances and then increase their efficiency and also minimize open connections and then timeout. You know that when that is how distribution does attacks works, right? Denial of service attacks works. If there are too many connections to a server, legit users or some users are not able to access it because there are too many requests at the same time and the server has to attend to them before they attend to you. So sometimes you may experience timeout. So in the situation where we have a lot of Lambda functions, right, doing connections or reading from our RDS, there might be an experience of timeout. So in this case, proxy is the best situation to use, right? And yes, for proxy, as I said, there is no code required, but there is something called elastic cache. For elastic cache, you will do some heavy coding. So probably when we reach database, as I said, we reach database in our official solution architect journey, then we'll look at it. By that time, we might have watched some foundational videos on the canvas and then we'll use the extra resources that we have to, back it up. Yeah, so I think that is basically about it. So when you are going through the labs, take your time. When you click on create database, take your time, and then now go through it. So you select. You can just play with a lot of. So there is Aurora, there is Aurora MySQL, and there is Aurora Postgres. Right. So you can go through it one by one, and then you look at it. Okay, let me select Aurora. I want to see where I missed the read. So you can have your dev test, you can have production. So credentials, you type your password here. And yes, you can choose either IO optimized or Aurora standard. Okay, let me include previous generation classes, best table. Still, anyway. So for the replica or reader node indifferent AZ, recommended for scale availability. Okay, this one I clicked on don't. I'm sure that is why. Public access, can either choose yes or no. And you cannot even look at additional configuration. This one is the port. Yes, for S3, for SQL is 3306. Database authentication, you can choose authentication method. For monitoring, you can go to additional configuration and then you can type a name for your initial database. And then for failover priority, you can choose tier 0 up to 15. And then enable encryption. And then, so even if I disable it, it will still create backups. Okay, so that's why you see there is enable backtrack. Okay, you can choose enable backtrack. And then for the backtrack, you can type up to 72 hours. So it means that you can do up to you can go up to what? You can backtrack up to the previous 3 days. Backtrack window determines how far back in time you could go. Or I will try to retain enough log information to support that window of time. So you can combine it with the, and for this encryption, I thought it was backup anyway, and then you can enable. Guys, I dropped off here.
Or your battery go off, your lights go off.
Yeah, I have it like battery saver. It turned on battery saver mode, so I'm sure that's why I dropped the connection.
Your lights will come back.
No, come on. What will be the time? 11. Maybe it will come some few minutes time.
That be why you make me like that.
So that's says about it. You can also explore. You can explore like a lot of them, right? So maybe Postgre can come to Aurora, but it works the same way, right? When you after you launch it, you'll be able to um connect to it just like we did yesterday, right?
Is it this one? RDS.
No, this is Aurora.
But I saw something like my this one, Microsoft S. Go up and let me see.
Yes. So you launch the Aurora from. So it's just the engine
Okay.
type that you choose, right?
Okay.
Aha. So it's just the engine type that you choose. So normally the name should be RDS Aurora.
Okay.
But then
So if you go and choose Microsoft SQL, that means you are doing RDS then.
you are doing RDS Microsoft SQL.
Okay.
Uh-huh.
Okay. So when you choose Aurora, it goes to Aurora.
Then it goes to Aurora. So you can see immediately you choose the name. When you choose this one, you see just Amazon RDS for SQL. And then when you choose this one, the description changes. Aurora MySQL. Yeah, so all the information I even some of the things that I said, you can see it's here. Up to 128 TB of auto scaling, exists-way replication across 3 availability zones, up to 15 read replicas with replica lag under 10 milliseconds, automatic monitoring with failover, up to 5 times throughput of MySQL community education. So, so I didn't lie. And then there are a lot of versions here that you can choose, right? So the current version is 8.0.32, right? You can choose to go with the current version. You can just play with it, right? With Diagro, right? As far as you are not launching it, you can still play with it. So,
This one, what
yeah,
do you call it? The RDS.
yeah,
Does it also have read replicas?
yeah. So for RDS, you when you do a multi AZ, right? When you do a multi AZ deployment, yes, it creates read replicas for you as well.
Okay.
It creates read replicas for you as well.
So
So
which one would
so
you advise?
no, so for
Maybe
yeah,
a very huge. You have maybe a mid-sized database
yeah. So if you have a
where
mid size, you still have to
keeps
choose
coming.
the you have to choose a multi AZ.
Yeah. Oh, but you let me land with a question.
Okay.
Have a lot of data coming in,
Yeah,
and also you run reports almost every hour. You run reports on that same database.
right.
So as you can see, there's stress on it.
Yeah.
As data is going in, data is coming out for reports and all that.
Hmm.
Usually, AWS advises that we read replicas.
Yeah.
So you have two databases. When the information comes into the main one, then it replicates in the second one.
Yeah.
And as we all know, it can be done within 10 milliseconds.
Yeah.
So then you design the reports to feed from the read replica.
Yes.
So in this scenario, would you choose um, the RDS with a multi-AZ, or you would choose the normal Aurora with the read replica?
Yeah, so depending on the workload. So I think so now we are aware of the performances, right?
Mm-hmm.
Performances of each of them. Now, Aurora works 5 times better than my SQL on RDS or my RDS,
Yeah.
my SQL, and then 3 times
Mm-hmm.
better than my RDS Postgres. So
Okay.
looking at your workload, if RDS won't be able to do that, then it is
You
better you
migrate.
yes, you better use Aurora. And then now, if it is just a read, write, read and read, write, right? There is for the read, you can enable Elastic Cache for the read node, right? For the reader node, you can enable
Okay.
Elastic Cache so that the data that are read are cached in memory, so that the stress doesn't go through the read replicas straight. You get it? And then for
Okay.
yes, and then for the router node, the writer node, you can also do the multi-master. If it's like a lot of write processes, then you can do a multi-master kind of
All right.
work. Then so that it will be more efficient, right? And if it is in the case of multiple connections, okay, so
Yeah.
you are doing like a lot of writing, another person is also doing a lot of writing onto the same database, then you are looking at doing a proxy system,
Okay.
so that the proxy will now pull the connection from the master database or from the database itself, and then now share the connection with you. So your connection is always hitting the proxy server before it goes to the database. So it also reduces the stress on the database,
Okay.
right?
All right. Cool.
So I think one thing that we should also put in our head that because these labs, we don't want to incur a lot of costs, right? So we are always looking at the minimum cost possible. But in a normal organizational setting, what you are doing is you are doing a cost effective setup. Now, cost effective doesn't mean that you shouldn't incur costs at all. You choose the best, right? But the most cost effective architecture. Normally, the cost effective architecture is not about choosing uh, the cheaper way out, but the most efficient way out that is actually going to save time. You get it? So if you are able to set up a system or an infrastructure that maybe sometimes we need to work just 20 minutes, and then we're able to set up an infrastructure that we can be able to work under 15 minutes, you have saved the time. So you have saved usage time. That will in turn convert to what? Money. So at the end of the day, there is still a return on investment, or that investment is worthwhile. So we have to also look at those things, right? In your bid to um, architect a cost-effective infrastructure, you are still considering efficiency, so that we wouldn't have more runtime, right? That will cost us a lot of money. So that is another thing that we should also put in mind. Because imagine you say you want to save cost, and then you set up a database system with a T2 micro. That's a lot of cost, because you are going to have a lot of working what's it called? Working hours. So you are setting up a database, and then let's say you go for the free tier. That is going to cost you how much? Just 14 USD a month. But this means is that more work hours. So this is like the minimum, the average. You can end up incurring more costs because the system is might not be what efficient enough. Hmm. Another question. This people should bring my light to. So in the absence of any question, I'll stop the recording and then we'll deal with other matters.